Well, hello everyone. So you're not in the wrong place. This is the talk. How did our DevOps team just become another silo? I alternatively named it "Practical Guide to Not Building Silos," and how you can do that is automate everything. Easy, right? Not so much. So I do want to highlight some of the discussion points today and what I will be covering. I'll define what exactly are silos in terms of in organizations, such as technology and development-focused organizations. And I will be talking a little bit about the anti-patterns in terms of, in my opinion, DevOps as a team or as a position isolated within an organization is actually an anti-pattern, and we'll explore that a little bit. We'll compare what a high-performance organization looks like compared to a low-performance organization, and that feeds back into the KPIs, which are key performance indicators, or what can we measure our organizations by to see that we're moving in the right direction. And then finally, we'll talk a little bit about the transformation process. What are some of the things that we need to focus on automating in order to move our organizations into that high performance category? Along with that, we'll talk a little bit about human ops and culture and empathy. So I first want to kind of talk about who I am. I'm not a robot. That's actually our company's mascot, and they pay me to put that there. Literally, they pay me. So I'm a developer evangelist for a company called Instana. We are an application performance monitoring company. This is not what the talk is about. We'll cover a little bit about it in one of my slides. But I joined Instana in April of this year after using them as a customer and being so impressed with the technology and what they did that I was like, I have to work for these people. And luckily, they hired me. So I'm very fortunate in that. So I began programming when I was about 8 years old on a Commodore 64. It kind of tells you how old I am. And I really didn't stop. From that point, I'd always been fascinated with computer science and building my own applications and my own tools. And that translated into a lot of the companies that I had worked for. I not only built applications for our customers, but I built tooling internally so that our developers could quickly get their applications running locally, and as well as we could get those applications into production. Sometime around 2014, I read an article about Docker, and I was fairly compelled about what I'd read. And I thought to myself, this is going to change the way we do things. And here we are about 4 years later, and Kubernetes is eating everything. And I think it's a good thing, to be honest with you. Now, 6 months after I read that article, we were using Docker in production at the company I worked for. And from there, I've worked with a few different companies putting applications into production utilizing Docker. With that work, I also did a lot of community evangelism, building up a Docker meetup group in my hometown in Nashville. Some of you may have heard of Nashville, Tennessee. It's a small town in the United States. Well, maybe not so small. We have over 1 million people now, so we're growing. And this year I'll be organizing the DevOps Days Nashville conference, which is pretty exciting and daunting at the same time. You can reach me on Twitter if you like, and some of my things I like to do in my spare time. I like to read history books, sci-fi novels. I like playing Minecraft with my 5-year-old. He loves it. Cycling and playing board games and RPGs as well. So speaking of my 5-year-old, hello. There we go. So that's him. He's getting his arm x-rayed because, I don't know, if I seem a little out of it, I was woken last night at 1 o'clock in the morning to a text from his grandparents saying, "Don't panic." Right? So it turns out, so my wife and I, we flew out here last weekend, and we've had a lovely time here in Sydney. But on Monday, apparently in the aftercare, which is where if you don't pick up your kids from school right at 2:30, they go into this aftercare program where they get taken care of for a few hours until you can get around to pick them up. And since my grandparents are watching them, he's in there for an hour or two, and apparently he fell on Monday and broke his arm. And so I'm asking myself, why is it that it's Thursday back home in the States? Am I just now hearing about this, right? And apparently he knew something was wrong, but he also didn't want to go to the doctor because he'd have to get a shot. And that's a really compelling story, I think, for a lot of what we're going through in the organizations we work at, right? So, it's we know something's wrong, it hurts, but we don't want to go necessarily fix it. We don't want to have to go look at that technical debt. We don't want to have to go and dig and figure out what's really dysfunctional about our organizations. And so I thought it was a perfect opportunity not only to talk about DevOps transformation in general, but a plug for my cute little 5-year-old. So what are silos, right? I think silos can easily be defined as processes or tasks within your organization that are manual, that simply haven't been automated yet. I think some good examples of that, say a release engineer pulls an artifact from a file system, logs into a server, and tears down the old app and manually deploys that artifact. How many people here, is that how you release software today? Anybody? No, thank goodness. The company I worked at last time, that was in their legacy stack, that's how they did things. They had a script to pick it up, but still the release engineer had to go grab an artifact, drop it in a folder, and a script would pick it up and it would deploy it. Another option is creating a ticket for the ops group to add a DNS entry for a new application or service. Anybody familiar with that? Yeah, at least I got a couple hands. Great. All right, so the point is that these are things in which we all know could be automated, and we're all not really sure why it's not. I think the point of this talk is that you're going to have to automate those things if you want to move into these high performance category, and I'll talk about what that means here in a moment. My clicky doesn't really want to work too well. So, who's here seen the DevOps Figure 8 before? Plenty of people, I'm sure. So on Martin Fowler's blog, which is a pretty prominent programmer, if you've never heard of him before, it says that a common anti-pattern is that we put these people in positions to where they are asked to automate all of this. How many here think that's even possible for one person or a small team to do all that? Realistically, I've never had anybody raise their hand. So, what do we do about this? How do we push past this idea that this is only one person's responsibility or one team's duty to take care of this? So, I guess my next question is, how many people have read this report? It just came out a couple weeks ago. Okay, great. So, on top of talking about what's inside of this, there's a lot of stuff I don't talk about. And if you've never seen this, they've done it for probably 3 or 4 years now. And it's a fantastic analysis of DevOps in general and automation within organizations, more specifically modern software delivery organizations. Now, I see some of you taking some pictures. I will share these slides afterwards on my Twitter. So, I doubt this is going to show up, this URL, but it is there in the presentation that I will share later. All right, so what are these KPIs that I alluded to earlier? What are these indicators of performance in our organizations? Now, I'm not sure who said it, but if you can't measure it, then you can't improve it. This is a fairly common accepted idea of why we measure things and why we assign numbers to arbitrary ideas so that we can improve them. So the two things we're going to talk about is throughput, and the next one we're going to talk about is stability. But first is throughput. How often can we deploy software, and how often do we deploy software? As well as lead time for changes. And what this means is Joseph up in accounting says, hey, I've got a new field I need you to put in this form, and I want a report run on it every 2 days. How long does it take that requirement to get out to production? And in short, it's simply measuring the velocity of your application delivery organization. So the next one is throughput, which is deployment frequency. We already talked about stability, which is time to restore service, or MTTR, and change failure rate. And this is the idea that whenever we do deploy something, how often does it break? And you'd be surprised at how often things do break. Or maybe you won't, because you all do this. So again, we're going to look at the difference between high performers and low performers, and what the KPIs look like for these two organizations. There's one that sits in the middle called medium performers. I know, surprising. And then there's elite, which I don't necessarily go too deeply into the elite statistics, because I think that realistically, I mean, if you're in here, you're probably not a high performer. You're probably somewhere in between medium to low. And if that assumption is wrong, please correct me. But I know that for most people, we're in that low to medium category. So, you know, low performance, how often do we deploy? Anywhere between once per week or once per month. With the high performance, it's anywhere between 1 hour and 1 day. For the lead time for changes with the low performers, it's anywhere between 1 month and 6 months. And with the high performers, it's anywhere between a day and 1 week. For the mean time to recovery, or oh crap, something broke, how long does it take to fix it? It's anywhere between 1 week and less than 1 month for the low performers. And for the high performers, it's less than 1 day. And then for the change failure rate, this is really shocking. And it probably doesn't come to a surprise to most of you, but with the high performance, who have substantially more deployments, have less change failure rate than the low performers. Can anybody guess as to why that is? Bingo. That's absolutely right, because the high performers are pushing out more code more frequently and less code per deploy. And not only that, but they've gotten really good at it. Like they've practiced deploying. Like if you only deploy software once every month, chances are you're going to screw it up because you're not doing it that often. You know, it's one of those things where if you know, I haven't been on a surfboard for 8 years, I haven't been on a surfboard for 15 years. But if I get out there and do it, I'm probably going to fall. And it's just how it is, I think. So, hello, Clicky. All right, so I did not share. Anybody interested in what the elite performers are doing? Yes. All right, so the elite performance, how often they deploy on demand, whenever they want, multiple times per day. Netflix, AWS. These are some of the people who are considered an elite performer. Lead time for changes, less than 1 hour. That means somebody comes in with the requirement, and within an hour, that's out the door. Mean time to recovery, less than 1 hour. And the change failure rate, same as the high performance, 0 to 15%. So how much manual work are these organizations doing based on their category? For the low performers, shocking, more manual work. For the high performers and the elite performers, less manual work. Does this come to a surprise to anybody? No. So now this particular graph is really interesting, and I apologize if you can't really read it. There's only so much you can fit on a screen. And this is the J-curve of transformation. And what this is when organizations start pursuing this path of automation. And I want to point out that here, I think it's really important, the word teams. This isn't an individual team effort or even an individual's efforts. QA, dev, ops, project management, all of these teams have to buy in and have to execute on this for it to be successful. You're only going to get halfway there. And more than likely, you're going to expose more technical debt getting to that point, which is what you're seeing right here, before you ever get to fix it, if you don't have the support of everyone behind it. So in the first one, like I said, organizations start identifying the quick wins and they start executing. In the second step, which you see that rise, automation starts helping those low performers push into that medium performance category. And realistically, this is where trouble starts happening, because we've addressed the quick wins, right? The easy stuff. And now we start looking at the hard stuff. And a lot of times organizations will actually regress because test requirements start skyrocketing. Old habits start to kick in and we start doing things manually again because, quite frankly, what is happening? What did we just uncover? So if we do keep progressing and we keep pushing, the organizations will start paying off that technical debt. Tooling starts getting implemented, such as schema management tools, deployment automation tools, such as Kubernetes, Docker. I think one that's really popular with .NET is Octopus. I've never used it. And then eventually, the pinnacle of DevOps is achieved. So relentless improvement work leads to excellence and high performers. High and elite performers leverage expertise and learn from the environment, and they learn from each other as well. So what's the story that you should walk away from this? Focus on automation. And that's what we're going to talk about here in the next few slides, is identifying what do we need to automate and how do we do it. So we're going to look at testing, we're going to look at database management, and we're going to look at deployment and operations. The payoff is we see increased velocity and stability in our organizations. So test automation. I think it's pretty evident that adopting a multi-factor testing pattern, and what this means is that organizations have to leverage unit testing, integration testing, and system testing to be successful in test automation. You can't just pick and choose. Everybody has to be on board. And realistically, what we're doing here is we're reinforcing every facet of the SDLC. And what this means is that every component and every corner case is explored and tested so that whenever we do introduce a new change to the system, we have fairly high confidence that we're not going to, set the whole place on fire. And of course, manual testing should be avoided if possible. I realize this isn't always feasible. However, I think that when you are faced with that decision to do manual testing, everybody has to buy in, and everybody needs to be aware of what the cost of that is. So the next one, database automation and schema management. Or if you're web scale, MongoDB, you don't have to worry about it. I'm being sarcastic. So Dora actually reported on database automation for the first time this year, after about 4 or 5 years of not really talking about it. And I kind of took it for granted because all of the organizations that I've worked for, save one, we leveraged schema management tools to do our database migrations. I've worked with shops that had PHP, Java, and Ruby on Rails. And each one of those technologies included Doctrine, Flyway, and Active Record. Now, I wanted to ask because I couldn't really find a clear answer on the internet. Google failed me. I don't know how this happened, but the .NET equivalent of those tools. Does anybody have? Okay, awesome. I'm going to write that down later. All right, so I think the first thing that we have to make clear is that manual database changes no longer allowed. It just cannot happen if you're going to scale and become a high-performance organization. Database migration systems are utilized. Again, entity framework, Doctrine, these are all things in which will help you make that transition. They're not perfect. They do break. Just be prepared, because when they do, it's usually really messy. Schema changes are usually executed during the build and deploy stage of the process. This throws in another interesting wrench, because if you're deploying services rapidly, meaning every day or multiple times per day, it's not really feasible for you to take your applications offline. You have to leverage some sort of deployment strategy such as Bluegreen. And if you leverage Bluegreen deployments, that means your schema has to be backwards compatible to be able to be able to use two versions of the same software at the same time. This is really challenging for anybody who's done development and actually had to use these type of tools in that type of environment. And again, use a schemaless database if you're awesome. You know, I say that at tongue-in-cheek because we did do that at Franklin American, which is a mortgage company I worked at before I joined Instana. We decided to use Cassandra and we used Kafka to handle the inter-service communication. And we used, and these tools were schemaless, but we ended up building frameworks around these systems to introduce schema-like patterns. So it was asinine. And you know, it was also pretty neat to watch from a standpoint of with Kafka and Confluent Stack, they have a technology called schema registry, which allows you to evolve schemas in an interesting way that makes it a little bit easier. Once you master the technology, it makes it a little bit easier to have those two services running side by side, because that technology specifically addresses backwards compatibility. Whereas your plain old RDBB, whatever, doesn't. Sorry, like I said, I've been up since 1 o'clock. So automating deployments, we talked a little bit about that already, the blue-green stuff, and I do want to ask the audience, how many here are familiar with that term, or how many aren't? Okay, great. So blue-green deployment is this idea that you have a blue service. Let's call this service version 1.1 running on your servers. And you have a new change, version 1.2, that you want to deploy. Now, when you deploy version 1.2, there's still customers using version 1.1. And you have to drain that connection pool before you can completely move over to version 1.2. The idea with Blue-Green is that you have 100% availability during this transition, because as the system is draining from the blue side of the deployment, new users are coming up on the green side, version 1.2. So where the challenge with that comes, and we talked about that just a few moments ago, is with the database and the schema changes. So I think the first thing that we have to talk about, though, is always deploy your artifacts through an API. And why do we want to do this? Well, because despite, I have built deployment systems before, and as much as I love them, they are nowhere near as good as the technologies in which thousands of people have contributed towards and built over the past 5 years. This includes technologies like Docker Swarm, Kubernetes, Nomad, Mesos, and from what I understand and what I've looked at of Octopus, even that is a great piece of software that a lot of people use. So treat infrastructure as cattle rather than pets. So this notion is that, you know, if I lose Roscoe, my little cat, I'm sad, right? I don't want to lose my cat. I love my cat. But I have 1,000 cows out there. If one gets lost, yeah, that sucks, but it's not the end of the world. I'm not out Roscoe, who kills mice and stuff. So again, this requires stateless services, and this also requires services to be compatible with that blue-green methodology of deployment. Now, the interesting thing with the blue-green is that once you start using this deployment pattern, you can begin leveraging more advanced deployment patterns such as canary deployments. And these are deployments where you have, it's blue-green essentially, but on the green side, you're only running 5 or 10% of your load on the green side so that you can confirm hypothesis that is this new service going to introduce a performance regression or errors? Yes, pull it out of the pool and let the blue side keep running. Again, these are advanced deployment technologies, but with the deployment APIs such as Kubernetes, this becomes much easier than it used to be. I figured it out. I have to point it. All right, so this is the part where, disclaimer, mini sales pitch, it's not much. Now, Dora doesn't really specifically talk about automating alerts and monitoring because I think that it's still a pretty new concept. This idea that if you build up a catalog of predefined and well understood patterns that emerge in these common technology frameworks such as .NET, Java, Spring Boot, Laravel for PHP. I mean, there's a ton of them. Express for Node, Ruby on Rails. Like, you have a good understanding of what these technologies look like when they're performing badly or they're failing. Like, for instance, with a .NET application that serves web requests, if you're suddenly getting a bunch of 500s and you weren't before, this is a bad thing. Why are we still writing alerts around this though? Like, why don't our alert softwares already understand this? And on top of that, why don't they have artificial intelligence around them and machine learning to understand deviations in those patterns? So, interesting thing about Autodiscovery is that so far with most Autodiscovery systems and monitoring, I've noticed that you have to define what you want to discover. Is that really Autodiscovery? I don't know. To me, Autodiscovery is the idea that new service pops up, we know about it, we figure out the endpoints on it, we figure out its dependencies, and we start analyzing those dependencies and those endpoints for trouble. Now, I also want to talk a little bit about the difference between observability and monitoring. So we talked about those known metrics, those known quantities, things like heap space, CPU usage, memory usage. These are things that we already know we can collect from our applications. Some of the things we don't know, this could include external requests from third-party APIs or third-party users. We also don't always know or define all of the endpoints that our services respond to. And we can collect that information though because it's all programmatic. It's all available there. Swagger is one of those technologies which go through and scrape everything. Why can't our monitoring be capable of doing the same thing? So the other thing that I think is really important, and this goes back to the automating and the testing and defining infrastructure as code. Why can't we define our alerts and our monitoring through code? Prometheus, which is a fairly popular technology now, actually allows you to do this. You can define all of your configuration in YAML up front and then push it to a server and have it deployed just like everything else. And then again, we touched upon the machine learning and the artificial intelligence. So if we do have a service in which has normally been emitting 200s, maybe a few 301s, maybe some 401s for unauthorized users, if all of a sudden we see a huge spike in 401s, we might recognize that we're under attack. Maybe somebody's trying to brute force their way into our system. There's a lot of things that we can do with machine learning and artificial intelligence that allow us to forego even defining a huge collection of alerts that, quite frankly, are probably going to be outdated in a few days, just at the velocity that we're currently going at. So the other thing that I did want to talk about is culture. And how many people are familiar with the Westrom model of culture definition? So you read the DORA report. So they talk a little bit about this. And they define culture across 3 different categories along 6 axes. Now, I don't necessarily want to talk about the categories, mainly because I think that in some ways within this model, most organizations fall somewhere in the borderline spectrum, like in terms of, a little bit of it. And it's hard to, I don't know, I'm trying to do a political analogy, but I realize that my politics aren't exactly the same as Australia's. So I'll just move on. All right, so again, the Westrom model has 6 different axes. These axes, the first one is the measure of cooperation, is information actively sought. And if we can ask ourselves a question in the form of, in my organization, is information actively sought? Yes, no. Well, a little bit. Well, is information repeatedly denied in terms of, I don't want to hear it because you're telling me something that requires more work? Failures are seen as learning opportunities. Messengers of them are not punished. This is a better way to ask this: are your messengers shot? In many organizations, this is the case. Responsibilities are shared. This is all about risk, right? I remember that when I was working at a company a few years ago, we had an issue where nothing could ever be decided. Nobody would actually approve a change or approve a request, because what that meant is all of a sudden they were responsible for it. And if it failed, it was their butts on the line. So another one, cross-functional collaboration is encouraged and rewarded. Bridging cross-functional teams, operations, working with developers to build out this automation. I think this is critical. And if your organization isn't at least addressing that, you're going to have a very hard time incorporating a DevOps model at your company. Failure causes inquiry. So this is an interesting one. I like to call these retrospectives. Some people call them postmortems. I'm not really sure why, because nobody died. If somebody does, sure, why not? The next one, new ideas are welcomed. Novelty is celebrated. So this is the idea that somebody comes up with an idea to do something new and revolutionary. We're like, let's talk about it, but yes, let's really embrace this and try it. And if it fails, oh well, we'll just try something else. So one of my favorite topics is human ops, and you can actually go to the website humanops.org, and they have some pretty good essays and articles about this idea that humans build systems. Humans need downtime. We get tired, we get stressed, we have feelings, we get happy and sad. And our well-being is directly proportional to the systems that we manage. And as a result, our health impacts business health. So what should we do about this? Document everything, teach everyone, save time. And then finally, and this is what all I was saying at the beginning, is automate everything. Escalate to a human only when possible. I don't know about you guys, I do not like getting woken up at 2 o'clock in the morning. And I don't think we should accept that as the normal. That's my opinion. I might be wrong, but who knows? So I did want to talk a little bit about empathy, and I think this graphic illustrates a little bit of my feelings on it. So I think this does tie in with culture, and I think it's worth mentioning, given the recent uproar. A fairly well-known programmer, you guys might know him, shared that he was apologizing for his behavior in the past. He called it unprofessional and uncalled for. And I remember seeing some of the things that this person had posted, and I'm not ashamed to admit that part of me, it was enjoyable seeing this person go off the rails. But I really didn't think about the impact it had on other people in the community. And I understand that a little bit now. I'm older, a little bit wiser. But in any case, a code of conduct or a code of conflict was changed to a code of conduct. And I think that says a lot. The language within it that may have been used to enable some of those behaviors was completely eradicated. And I think it's important to point out the explicitness of this code of conduct. I think that we all understand what it means to be excellent to each other. Don't be a jerk. But in reality, I think it's important to have clear definition of what that means, just so that there isn't any ambiguity on that front. So ultimately, in the pursuit of excellence, I think we're called to maintain dignity, civility, and respect for each other. And the rules in this code of conduct, historically so far, they haven't gotten in the way of any of these projects' success. As a matter of fact, all of these projects use this code of conduct, including every .NET open source project there is. So with that, I do want to open up the floor to questions. I will be posting this slide deck up on my Twitter. If you want to go check out our monitoring platform, we do have a free trial. I welcome you to check it out and let me know how, give me your feedback on it. And I'm not sure where we are with time, but I'm pretty sure we have a few minutes for questions if anybody wants to shoot one this way. Yes, sir.
The overall idea of automating everything, I imagine that there's always got to be a judgment call in terms of you can't just spend all of your money working on automating all your processes when you actually need to sell something at the end of the day.
Yeah.
So what do you think about that trade-off?
All right, so the question was, in any organization, I think there's trade-offs, right? The idea that, well, we can't necessarily automate everything. What do we automate? And I'd have to say that when you start looking at the processes and the pain points in your organization, you identify the ones in which cause the most pain. Just like, my son broke his arm. At some point, whenever I think his grandmother, we call her Mimi, was playing with him and has pulled his arms to pick him up, it was that pain. He felt it, and he let everybody else know about it. And so when you start looking for things to automate, people are going to tell you what stuff causes them the most pain, right?
Yeah.
Does that answer your question? Sure. Anybody else? Yes, sir.
A quick way to be able to potentially, get an old school IT team that, sysadmins have done things the old way and they don't get DevOps. How do you get them on board?
Historically, so far, the best way to do that has been to hire a developer into their team. It's not so much that you can't teach an old dog new tricks, but it certainly is easier to get a new dog in there to do the tricks for you. And it's one of those things where I think most of the system admins that I've worked with, operations, they see the benefit of it really quick once they have someone on their team willing and able, keyword is able, to address that work, because this is a development problem. This isn't an operations problem. This isn't a PM problem. We need developers in there programming solutions to these issues. Do you have any other questions? All right. Well, I just want to thank everybody for showing up to the talk, and especially to NDC for inviting me out to speak. I appreciate it. Thank you so much.